For years, self-driving vehicles seem to be just around the corner. However, fully automated vehicles still haven't materialized yet. So, what are the challenges faced in this? To answer this question, we are happy to welcome today Professor Dariu Gavrila, who heads the Intelligent Vehicles Group at the Department of Cognitive Robotics of the renowned Technical University in Delft. Over the past 20 years, he has focused on visual systems for detecting humans and their activity, with application to intelligent vehicles, smart surveillance, and social robotics. He led the pedestrian detection research effort at Daimler, which was commercialized in several Mercedes-Benz models. He now performs research on self-driving cars in complex urban environments. In his keynote, Professor Gavrila will outline the current status and the future prospects of this transformational technology, and especially how implementation of robotics at scale needs to be aligned with actual human behavior and interaction. Please welcome Professor Gavrila.
So, good afternoon. My name is Dariu Gavrila. I'm heading the Intelligent Vehicles Group at TU Delft. And as was introduced previously, I spent 18 years in the German automotive industry working at Daimler R&D, where we were working on driver assistance. And we indeed developed a system, I with my team, for pedestrian safety, which is now actually implemented in the Mercedes-Benz SE and C class. Today I'm going to talk about self-driving cars just around the corner.
Ask a girl what she wanted to be. She said, baby, can't you see? I wanna be famous, a star on the screen, but you can do something in between.
So, self-driving cars, it makes a lot of sense. There are very good reasons for that. First of all, of course, the safety. 1.35 million people are killed yearly in traffic worldwide, and 95% of the accidents are due to human error. So, if we could have automated driving, the hope is that all these accidents can be, well, for a very large part, avoided. Then there is also the inclusivity case that certain people with disabilities might still participate longer to mobility and to traffic. There is a comfort case that instead of doing this pedaling and the steering, you could actually do something nice in a vehicle, like like communicating with friends or being productive. And last but not least, of course, there is a very strong economic case in the sense that certainly in the business of transporting people and goods, the aim, the hope is that by removing the driver, you can save a lot of costs. So very strong drivers. And so there is a potential indeed for this technology to revolutionize the mobility of the future. And always when there is this technology that can revolutionize things, it's very instructive to take a look at the so-called Gardner hype cycle. And this is a development model for new emerging technologies from the conception, which is to the left of the time axis, to the possible maturity, which is to the right. And you see that we're starting with a certain technology trigger, and so there are some proof of concepts, in this case of self-driving vehicles, People get excited, the media gets on board, then a lot of startups start appearing, people start increasing their expectations, coming up with even shorter deadlines and announcements, and at some point we are here at the peak of inflated expectations. And then suddenly things are not going that fast anymore. People get disappointed, the problem turns out to be harder than thought. And then you get a kind of a washout effect where a lot of consolidation takes place in the industry, and a lot of players go down, and maybe they're taken over by bigger players. And after a certain kind of realization of the main problems, at some point it goes upwards again, and the problems are being taken care of, and then you will see some realistic applications and commercial products appearing, and this is the so-called slope of enlightenment up to the plateau of productivity. So, when I started at TU Delft, I really think we were right here at the peak of inflated expectations. I got some quotes. Chris Urmson, which was the Google car chief, said, okay, my team is committed to making sure that my son doesn't need a driver's license in 5 years. Ford CEO said, well, we expect fully autonomous cars in 5 years. And of course, Elon Musk topped it and they said, well, we'll get fully autonomous Tesla by 2018. Well, we had 2 years of Corona, so we can add 2 years, but now we're in 2022, and where are these cars? So, yeah, let me go over this. Why aren't these cars driving in Amsterdam, in other places in Europe? Well, there are some legal issues that are still open, like regarding the revision of laws and making it harmonized over multiple countries. There are still rules need to be worked out for the validation of the technology, of how much does an OEM need to test a certain technology before it can be introduced in the marketplace. And of course, there are issues about ethics and liability. But I think these are not the bottlenecks for this technology. On the right side, we have the human factor issues, and these are very important, actually, to see whether this technology will make it into the marketplace. And so it's a question about people, whether they accept this technology, self-driving, whether they're actually willing to buy it, and they trust it. So what really is the bottleneck, in my view, is still the technology. So the technology is not ripe yet. And where are the problems with, where do things go wrong? Well, in tunnels, when there is darkness, in heavy rain or snow. So here the sensors are having problems. And when we talk about sensors, we're talking about cameras, we're talking about radars, we're talking about laser scanners. These are the three main sensors. And of course, if it's slippery, you have problems with the vehicle dynamics. Other problems are some objects that are really hard to detect for the perception. So yes, I can see that that is a green light, but do I see what light this is? Yeah, it's very hard to see, certainly if you're blinded by the sun. And it's also very hard to see for a self-driving vehicle. Then, who has ever had experience with debris on the road? Raise your hand. Who has ever had? I see a minority. Well, actually, I personally had some experience. I was driving on the German Autobahn at night. I was still having the normal beam on, when suddenly a whole row of truck tires showed up on the road, and I couldn't remember whether there was a car next to me, so I did the emergency brake. But this is what happened, and beside me there were 4 more cars that got into this mess. So this is something which is completely unacceptable for a self-driving vehicle on the highway. So it needs to have the sensors to detect very small debris, maybe 20, 30 centimeters already, at distances of 150 meters. So it's very, very tough. And talking about strange cases, very unusual cases, these are the so-called edge cases, and this makes it very hard for self-driving vehicles because you have to drive a lot, and collect a lot of scenarios that could happen. So this guy doesn't look like a normal pedestrian that we train on. Here we have an accident, we have a calamity. So what does the self-driving car needs to do? Who has its rules, its maps, and then suddenly there is an accident like that. This is a scenario for the city center of Amsterdam, and somebody starts taking out some equipment, and everybody's waiting, at some point getting very nervous of when is this guy driving away. But of course, there's no driver anymore in self-driving cars, so then wonder what will happen then. Another thing of a way of looking at it is the traffic scenario. So we have here the highway, which I don't want to say it's easy, but it's still relatively easy. Then we have the urban environment, which is already hard because you have cross traffic, you have cyclists, you have pedestrians. And this is a case in Phoenix. This is where some of the first large-scale tests were performed with self-driving vehicles by Waymo, by Google and others. So you still see that the road is kind of nicely wide, and there are a few cyclists and so forth. I think there is even a harder scenario. You don't have to go that far from here to get to some. You can go to Amsterdam, or you can come to Delft. And this is a typical, let's say, scenario in inner city. So here we are very close up to the pedestrians and cyclists. We see some strange cyclists. We don't maybe recognize this. We have bridges, right? It's very narrow, very close contact. And so here we need to navigate who goes first. The car or us. And, well, by the way, we are driving manually here, right? This is just detection. So take a look at this guy. Do we need to wait for this? No, because he's not walking here. But look at this guy. He's just going to walk into the road now, right? Boom. So it's a chaos, right, in the, let's say, some of our cities. It's a chaos. Here we see some problems with the dark shadows for the camera. There are cars parked on the wrong side of the road. We will soon come in a close collision scenario with a bunch of cyclists, which will be on collision course. So it just kind of shows how difficult it is. Let's take a look at these now. And then we get overtaken to the right. It's a chaos. I asked my students to get some nice footage, and within 1 hour I got the sequence. So it's not something that is very abstruse. We are very good at detecting the spatial surroundings of the car. So you see here the camera view with the pixels here on top. The circles relate to the laser scanner, and the dots are the input from the radar. So that's really good. Very good coverage, meanwhile, of the spatial environment. Then we would like to know not only that there is something, but the car would like to know what it is. It wants to distinguish a bush from a pedestrian. So classification, object classification is very important, and it's very much triggered by machine learning, AI, neural networks. So we need to get a lot of training data. And you can see here some work done by my students where we collected in 12 countries, 31 cities in Europe, lots and lots of data. And well, we see some results here of the detection results that are currently possible with neural networks. So evidently the green bounding boxes are detections by the system, and you can see that we can get people very quickly even if they come from occlusions. The red part is cyclists or riders. Now we come to my favorite part, the Parthenon in Rome. You're not supposed to drive here in the first place. My PhD students got 2 letters from Rome with fines of 200 euros each. But if you take a look at this scene and how well we're doing, I think it's worth for the science, at least, to see what's possible. It's just amazing what we can do, meanwhile, with deep neural networks. So that's that. But what's really the hard part is basically the prediction, what will happen next. So we are pretty good at detecting what's happening now on the scene. What will happen next? Let's take a look at this scene here. We're going to see some pedestrians coming to the street, and I'll ask you, this is a quiz time, which of these 2 pedestrians will cross? Who thinks that the guy in brown will actually stop Who thinks that he will stop? Okay? And who thinks that the green guy will stop? Okay, one guy. So why did you thought that the brown guy would stop? He's watching, right? So that's an important cue that the pedestrian has seen the vehicle. If you take a closer look, you also see that there is a change in balance, that he's already kind of decelerating and changing the balance. So there are very subtle cues. And up to now, also in the commercial vehicles, this is not part of a pedestrian safety system. It only looks at the position of the pedestrian. It's like a point. It doesn't look at visibility or basically other features. So, and about this guy here, it's very hard to say whether he will stop or not. So the answer is, should be, I don't know, right? But this one in front, we could handle. So we developed a system that also takes into account, has the pedestrian seen the vehicle, is the pedestrian at the curve, and is there any collision possible? And this is much more like a human driver would do it, so we're trying to make these systems a bit smarter and be more like human drivers. And of course, human drivers have a lot of experience, and we are using a lot of machine learning, where we learn from many. So we haven't really told the system you have to do you have to watch this and this and this. So the system has learned from many, many, many examples of how people cross, what are the important features, and what are the probabilities involved. So this is then basically the final result, where we here also output the prediction where the pedestrian will be in 1 second with the uncertainty region. And you can see how that plops to the curbside once the system detects that he's seeing the vehicle and also decelerating. Right. Okay, I'm running out of time. The same thing we can do also with cyclists. So this is a general approach that we're doing for motion prediction. Here, the cyclist can raise its hands, but this is optional. We know, the system knows that there is a road to the left. And so basically we can, by certain features, we can predict that there is an increased probability that the cyclist will turn to the left, and the prediction is shown here, and now the red one will go into the driving path, so that signals a danger. We have several levels of automation. The level 0 means no automation. Driver assistance, feet off, is level 1. If you can also take the hands off, is level 2. And then eyes off, conditional automation, is number 3. The brain of automation, meaning it's kind of a robot taxi, is L4. And L5 is that there is no steering wheel possible anymore. So what is basically on the market now, and what are the developments for the short term? Well, I think it's quite a milestone that we have now the first L3 system since December in Europe, in Germany. It's the in part of the Mercedes-Benz S-Class. And what you do is you turn this system on, and the car drives itself, and it does the longitudinal and the steering and the braking itself. Hey, wait a minute, this is already available for quite some time, right? You might have it in your car as well. Yes, but this is level 3, which means that the driver is legally allowed to do side activities. So he's now watching some very interesting movie, and later he will play some games, and this is allowed, right? Because the car will give him 10 seconds to take control back if there is a need to. So this is the part where you kind of gain quality time in the vehicle when you start being allowed to do some side activities. Well, there are still a lot of limitations to the system. It only drives up to 60 kilometers per hour. It cannot overtake. There has to be a car in front. So it's kind of a pesky conditions, but it's a first start. Some very cool stuff is happening in the US, in particular in Arizona, as I pointed out, and in San Francisco, where you have companies like Cruise and Waymo that really had started last year already with large-scale tests with still their employees at first. But now, well, at least Cruise has announced that they started last week taking paying customers, right? So there are a couple of routes in San Francisco where they start these routes where people can actually order their cars and drive without a driver. It's very cool. And apart from driving people around, transporting goods, like pizza delivery or some other stuff, is going to be a major application of self-driving vehicles. As you can see here, some goods are being transported. So this is the last mile, so to say. This will replace the Albert Heijn bus or the Amazon delivery, DHL. So it's very exciting in the logistical sector. And last video I have here is the one on trucks, where you want to go from big distribution centers to other distribution centers. So this is basically traffic that will be on the highways. And there are first pilots on that as well. So I think that's a very exciting thing. It's still in the pilot phase, so it's not totally robust yet. Okay, so I come to the pre-last slide. We talked about, are they around the corner? So yes, they are, and let's take a look what will happen next. This is a prediction. So right now we have these hands-off highway pilots and remote parking pilots. We already started, as I mentioned, the Mercedes S-Class is the first one for autopilot with eyes off, where you can do side activities. So in the next few years, you will see the systems being much more general and much more regular conditions, so not just like up to 60 kilometers and so forth. So much more like, okay, 120, 130, free driving, overtaking, and so forth. Then I think it will take up to 2030, where you can really have some type of a taxi, robot taxi for the highway. And if we take a look at the higher automations where there are these robot taxis, I already talked about the first large-scale tests. So I think we'll see in a few years these services also come to Europe and also to tough cities like Amsterdam in some favorable conditions, meaning on very specific routes. And we will also see some nice installations of automated valet parking. That means that you go to some parking lot and you step out and the car will park itself, or maybe even some fancy restaurant will offer this. So personally, I think that it will take after 2040 until these vehicles will have the same flexibility of driving around cities like Amsterdam, like the human. So this is like still 20 years, and this is kind of a nature constant to say, well, this is going to be quite some time, and we don't really know. But I would bet this would be at least still 2040. So are they around the corner? Yes, they are. Some already have arrived, some are just around the corner, and others will take quite some time to get to the corner. And the question is, what will we do afterwards, after 2040, when everything is solved? Well, there's going to be sufficient work left to do, I think, for us. Thank you very much.